Hello everyone. In this video, we will talk about the exciting concept of sealed classes introduced with Java version 17. In this video, we will talk about what are sealed classes, talk how sealed classes can help, providing some use cases for it. And finally, we'll explore sealed classes by demoing a real-world scenario where it can be useful in a payment processing system. Sealed classes and interfaces restrict which other class or interface may extend or implement them. To declare a sealed class, use the sealed modifier followed by the permits clause to specify the subclasses who are allowed to extend the sealed class. So in this example, the sealed class shape can only be extended by the circle class and the square class. Now each subclass has to have a required qualification of one of three types. Final, meaning that the subclass cannot be extended further. Sealed, meaning it is possible to extend it but only by its permitted subclasses. When you have a sealed class, you necessarily need to define permitted subclasses. And non-sealed classes, which can be extended by unknown subclasses. A sealed class cannot prevent its permitted subclasses from doing this. So shape may only allow circle and square to extend it, but circle can be a non-sealed class and it can allow any subclass to extend it. So now your next question might be, what is the need or when should we use sealed classes? First is the control inheritance aspect. So if we want to restrict class extension to a predefined set and prevent unauthorized subclassing, then sealed classes make sense. For example, say we are developing an API for a graphics library and you want to limit shape types to circle, square, and triangle to ensure consistent behavior across all implementations. And we do not want anyone else extending the shape class and creating an implementation which we do not want. Type safety and exhaustive handling. This ensures all possible subclasses are known at compile time, which enables exhaustive checks. This also improves code organization where related types are grouped together. So for our demo, let's develop a payment processing system for an e-commerce platform. We have various payment methods like credit cards, PayPal, and bank transfers. Each method has its own processing logic, but you want to ensure that only specific known payment types are allowed in your system. And this is where sealed classes come in handy. Here I have IntelliJ open. Let's create a new project. Name it sealed demo. Click create. It creates a main class for us. We do not need this, so let's right click and say delete. Let's maximize this window. Right click and say new class. Call it payment method. Now to make it a sealed class, let's add the sealed keyword here. With a red squiggly line, it tells us that a sealed class must have subclasses. So using the permits clause, we define the allowed subclasses, PayPal, bank transfer, and credit card. We see these in red since we have not created these classes yet. Let's do that next. So hover over PayPal, then go to more actions, choose create class PayPal, choose the same package. Now since it's a permitted class, it needs to have one of the qualifiers, final, sealed, or non-sealed. Let's call it final. Go back to the payment method class. Do the same for the bank transfer. Choose more actions. Create bank transfer class. Same package. And let's make this one non-sealed so any class can extend it. And finally, do the same for credit card. New class. Same org.example package. And let's make this one sealed. And so like we know for a sealed class, we need to specify the permitted subclasses. Let's say here permits Visa card. Hover over Visa card, more actions, same package. It's in red as every permitted class has to have one of the qualifiers, final, sealed, or non-sealed. So let's call it final. Let's now create a new class. So right click, new class, call it Venmo. And let's try to extend it from payment method. We see a red squiggly. indicating that Venmo is not allowed in the sealed hierarchy. We can, however, extend it from the bank transfer class, which, even though is a permitted subclass of payment methods, is a non-sealed class and so allows extension. In my opinion, it defeats the purpose of the sealed hierarchy. I would make all the permitted classes of a sealed class as final to truly stick to a control inheritance. Now, credit card is a sealed class which permits Visa card. A sealed class should have access to all its permitted subclasses, so they should be a part of the same package. So Visa card is also part of the same package or.example, and so it's fine. Let me create a new package. So right click, say new package, call it org.demo. Move the Visa card class to the new package. Now we see a red mark against Visa card. Class is not allowed to extend sealed classes from another package. So they need to be part of the same package. Let's move it back to the same package, and it's fine now. Let me delete the Visa card class. The other way, if the class is not in the same package, is to create it as an inner class. So going back to the credit card class, mark it as sealed, permits Visa card, hover over Visa card, in more actions, say create inner class, and since every permitted class should have a qualification of final, sealed or non-sealed, let's call it final. Now, if the extended classes are all internal classes, then we can even remove the permits keyword and it should be still fine. So, by using sealed classes in this payment system, we have created a closed set of payment types, preventing unauthorized additions. We get a compile type safety. If we add a new payment method which is not permitted, the compiler stops us from doing so. And so there you have it. We have seen how sealed classes in Java 17 can be applied to a real-world scenario like payment processing. They offer a powerful way to control class hierarchies and improve type safety and make your code more robust. Thanks for watching.